There is another formula to measure the electric power. Now let's see the formula for electric power. Power is equals to work done upon time, which is represented by T. Now, this work done is also represented by a formula which is V, I and T. What is V? V is the potential difference, I is the current and T is the time. How we define work in this particular condition? That W is the work done by the current I when the potential difference applied is V in time T. So this is how we define work done, which is represented by W. That is the work done by the current capital I when the potential difference V is applied in time T is known as work done. So now you will replace this W into the formula of power. Now replace it, you will get V into I into T and it is divided by a time. This T gets cancelled out, you will get the formula for power, that is V into I. So new formula for power is V into I. What you will conclude from this formula, that power is directly proportional, or we can say it depends upon V, which is the potential difference applied across the appliance. Second, it also depends upon the current which is flowing in the appliance. So the new formula for power is potential difference multiplied by the current. How can we define this formula? See, we can define the formula as capital P is the power rating of the appliance when V is the potential difference supplied across the appliance in which the current flowing is capital I. So you can make the definition according to the formula calculated. If you have the formula in front of you, you can easily make out the definition from it. Now let's see the unit in this particular formula. The formula is P is equals to V into I. What is the unit of potential? The unit of potential is volt. What is the unit of current? The unit of current is ampere. So now the new unit of power is volt ampere. So that means it is equal to watt. Firstly, we have defined that watt is equals to joules per second. Now we can define that watt is equals to volt ampere. How can we define 1 watt in this case? It is equals to 1 volt multiplied by 1 ampere. That is, now frame the definition. I have told you if the formula is in front of you, you can easily frame the definition like 1 watt is the power rating of the electric appliance when 1 volt potential difference is applied across it and 1 ampere current is flowing through that particular appliance. So this is how we can frame the definition according to the formula. Next, the very important term is commercial unit of power. Apart from this, there are other formulas as well for electric power. Now you have to draw the formula where the formula consists of only V and R. Now let's see, power is equals to V into I. Okay, now you know the Ohm's law. Ohm's law is V is equals to IR. This is your Ohm's law. We can reduce the formula for I, that is equals to V upon R. And we can put this I value into this equation. So what will be the formula for power then? It will become V into, instead of I, we are going to put V upon R. So the formula for power becomes V squared upon R. Now notice in this formula, you have the power in terms of V and R. No other terms are accepted here. Only the term V and R makes the formula of power. The second formula of power is in terms of I and R. Now, same procedure, P is equals to V into I. From the Ohm's law, we knew that V is equals to I R. Now you have to make the formula with I and R. So you have to remove V from here. Now put this value of V from Ohm's law into this equation. What you will get that power is equals to IR into I, that is power is equals to I square R. Now this formula contains only I and R and no other term is accepted. So we have seen that there are many formulas to calculate the power in the term of work done, in the term of potential difference, in the term of current, in the term of resistance and so on. You can take any of the formula depending upon the numerical. Whatever value will be given in the numerical, you can calculate the power accordingly. Now let's study about the power voltage reading of the electric appliances. What happened that if you have noticed some of the electrical appliances and you notice the label attached to it. If you still haven't noticed, then use a bulb, a rod, anything, any electrical appliance and notice the specification or the label which is written on it. Generally, the label written specifies some amount of numerical value. Like I am talking about the bulb. In the bulb, the label which is mentioned, it was written like 100 watt dash 220 volt. This is the numerical specification which is mentioned in the bulb. Now what it signifies? Say 220 volt, it signifies the potential. Okay, this is the potential which is supplied at every homes. I have already mentioned that in every home the potential which is supplied to us is 220 volt. Due to the appliances connected in parallel, every appliance has the same potential. That is, if we talk about bulb, if we talk about tube light, if we talk about TV, if we talk about fridge, all are having the 220 volt potential because they are connected to the main power supply and the main power supply is giving 220 volt. Now, so 220 volt mentioned in the bulb signifies the voltage coming in your houses. 100 watt. Watt represents power. That means your electric bulb requires 100 watt power. To find out the current on which this electric bulb is operating, then you can easily calculate out. How you can calculate? For formula is V into I. Power is given to you, that is 100 watt. V is given to you, that is 220. You have to calculate the current through which the bulb is glowing or operating. So, the current is 100 upon 220. You can divide it, you will get 0.45 amperes. That means that bulb who is having 100 watt power is operating on a 0.45 ampere current. So this is how you can calculate the current of any electrical appliance if the label mentioned in the appliance consists of a power and a voltage. So, this is a homework for you. I have done a bulb specification for you. You can take a tube light, you can take a fan, you can take a fridge, anything and just note down all the numerical specifications given on it and try to find out the current on which those appliances are working. Now, let's define the other topic which is much closely related to that of the electric power. That is electrical energy. We have seen that electric power is given by work done upon time. What is this work done? The work done by the current. What is this time? The time taken for the appliance to operate. Okay. So, this is the formula which calculates the electric power. I have already told you that the amount of work done is equal to the energy consumed. That is, if you are running and some work is done, so in order for you to run, that is in order for you to complete a certain work, you require certain amount of energy. And that energy is proportional to the work which you are doing. It is the same case in the case of current also. The work done by the current when it is flowing in the conductor is equal to the amount of energy consumed by the conductor. You can understand it in this way also. Let's suppose a fan. Okay, you have switched on the fan and the fan starts operating. The fan, when it starts operating or revolving, it is doing some work. But how that work is done? Because it is consuming some amount of electrical energy from the electric circuit. So, when the fan consumes some amount of electric energy, then it revolves or it performs a work. So, this is, I want to tell you that the work done by the current is equals to the electric energy consumed. Okay, so instead of work done, you can write the electric energy. Now the formula for electric power becomes is equals to electric energy upon time. Now the formula for electric energy becomes, you can rearrange electric energy is equals to electric power into time, that is P into T. So this is the formula for electric energy, that is P into T. So how you will define the electric energy? The electric energy is the energy which is possessed by the appliance having a power P in time T. Now let's see the unit of electric energy. Electric energy is given by P into T. What is the unit of P? That is power, it is watt, and time is measured in hour. Okay, so unit of energy is watt hour. Now watt hour is a smaller unit of energy. It is used to measure the smaller quantity. If you need to measure a bigger quantity, then the unit would become kilowatt hour. Kilowatt hour is a commercial unit of electric energy. It is used to measure heavy appliances, or it is used in industries, or in order to measure larger quantities, we use the kilowatt hour. The SI unit of electrical energy is joules. The joules, that is the work done. The electric energy and work done both are the same thing. So in order to measure the smaller quantity, we generally use joules. But when we have to move toward the commercial side, or when we have to measure a bigger unit of energy, then we use kilowatt hour. Now let's see the relationship between kilowatt hour and the joules. 1 kilowatt hour is equals to 1000 watt hour. Okay, I have already told you that 1 kilowatt is equals to 1000 watt. Okay, so 1 kilowatt hour is equals to 1000 watt hour. Now, we have already defined what is 1 watt. 1 watt can also be written as 1 joule per 1 second. Now, substitute this value instead of W. What we will get that 1 kilowatt hour is equals to 1000. Instead of W, can we write joules per second? So, just write joules per second. Now, replace hour into seconds. This is hour. You have to replace it into second. So, how you will replace 1 hour into second? That is, you have to multiply it by 60. By 60, you will get the answer in seconds. Let's see. This is seconds. This is second. It will get cancelled out. Okay. Now, just calculate the value. 1 kilowatt hour is equals to, you will get joule. Okay, all the units are finished. Seconds are cancelled out, so no more unit is left. Only the unit left is joule. So just copy it down. Now count the numerical value. It is 1000, it is 60, it is 60. It will become 3600 and 3 zeros here. We can also write that 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joule. This is the very important relationship that you have to learn and keep in mind while solving basic numericals.